Okay, there it goes. So welcome everyone, good morning. We're the identiDoc team. We're one of the senior design teams from the University of Texas at Arlington's Computer Science and Engineering Department. We are also sponsored by State Farm. My name is Jonathan Marek and I functioned as the Scrum Master and a developer for this project. Rashan Shrestha was the product owner and a developer, and our other developers include Pawan Katka and Sandesh Coriola. So to start, our team was tasked with creating a technological solution to have a program recognize and process text from a document to classify it. After classifying the document, we were also able to identify if a signature was present within a certain section of the document. The outcomes learned from the identiDoc project are intended to determine the viability of a new approach of auto-accepting or auto-rejecting documents within the current State Farm processes. And the product we created is a full stack web application built on the Flask framework using Python 3. An official user interface exists, but all communications with the server is through a RESTful API. Therefore, it can be expanded to be supported on nearly any platform. And identiDoc is running on an Ubuntu server and uses SQLite 3 as its database. And now we will go to our live demonstration. So here you can see our landing page. This is the home page for our official user interface. And from this home page, the user can access all of identiDoc's functionality. The first major feature of identiDoc is the ability to upload a document for the classification. So from this page, the user is able to upload a file that will be classified and scanned for a signature. So I'm going to go ahead and select one of our class 3 documents. As you can see, there is a document preview once the document is selected, and the user can see it before they upload it to the server. And once I click upload, it is sent to the server, processed, classified, and the user will be redirected to a results page that shows the results. As you can see, this document was classified as a verification of student income form right here, and it also denoted that it found a signature. And I'll run it a few more times with some of our other documents. Here we have a class 1 document, which is our cost of attendance adjustment. And it goes through that same process as it gets uploaded to the server and is processed. This document did not have a signature, and it denoted that it did not find a signature on this document. Here we just have a JPEG picture of a document. This is one of our class 5 documents. It's a CPT student information form. And once again, the identiDoc identified it correctly and was able to detect the signature on that document. identiDoc is also able to, classify unrecognized documents, which are the documents that we have not trained it to recognize. So here I just have a DMV form that I filled out with some fake information. Whenever I upload that for classification and signature detection, it just comes back as an unrecognized document. We don't actually go through and run the signature detection module on unrecognized documents. And so the second major feature of identiDoc is the ability to be able to query and download previously uploaded and classified documents. So here's our query page. From this page, the user will be able to filter by the date that the document was uploaded, the class of the document, and whether or not a signature is present. By specifying none of the fields, you just get to get all of the documents that we've previously uploaded to the server. We can, for instance, filter by today, and we get all the documents that we uploaded today. The last 4 are the ones that we just uploaded through this presentation. And by clicking any of these links, we're able to download those files in their original format. So here we uploaded a PDF to the server, and we got a PDF back. Here we uploaded a JPEG, and it gave us a JPEG. And we're able to do that with a variety of image formats and PDF documents. So back to the presentation. So DevOps. identiDoc was designed with modern DevOps principles in mind. We developed an extensive unit testing suite that has 29 unit tests with 174 unique assert statements that resulted in 89% code coverage from all of our source code. And we also have a full CI/CD pipeline that is integrated through Circle CI. So every time that one of our developers makes a change to the remote repository on any branch, Circle CI runs the entire unit testing suite, and that provides us with instant feedbacks on any errors that may have been introduced in the previous commits, really before they become major issues. And that instant feedback is provided through email. Anytime that one of our developers merges a pull request into our main branch, Circle CI will update the identiDoc system on our production server, which ensures that the latest version of our software is always deployed. And here's just a screenshot of what our Circle CI dashboard looks like. As you can see, there's some jobs that failed the unit tests, and then we updated them, and they now passed. In here, you can see one of our test and deploy jobs where we ran our unit test suite and they all passed, and then we deployed it to our server successfully.
So the pre-processing module mainly focuses on text abstraction, which we use for classification. So we went ahead with 5 different types of files, which were all obtained from UTA. And in total, about 1,000 samples were used during training and testing the identiDoc project. Next slide, please. So the first step during pre-processing is file conversion. So a user may upload an image or a PDF. So the first step is to convert them to a CV2 image. Next slide. Next, we check for file orientation. We check the angle. So we always make sure the CV2 image is upright, which gives maximum efficiency when we feed it to the PyTestRack model. Next slide. The CV2 image is then converted to a grayscale image, and we make sure that the pixel values are within the range of 0 and 255 using a threshold. Next slide. The thresholded image is finally fed to a PyTestRack module, which extracts all the text for us. We make sure that single characters are whitelisted. Next slide. Once we have the extracted text, we lematize them. Lemmatization is to change words to their basic form. Then we remove commonly used words like is, see, etc., which are known as stop words. Once we have the final version of the extracted text, we finally feed it to the classification module. Next, Sandesh will be talking about classification.
Good morning, everyone. I'm Sandesh Koirala, and I will describe the classification model used in the system and how we built it. Can you move to the next slide, John? Yeah, okay. If you look at the table, it displays 10 randomly selected rows from the dataset. The first column with bold numbers is the row ID. The second column is the text extracted from each document, and the last column is the document's class. So we used about 1,000 data points divided into 5 classes of data, each class corresponding to the different type of UTA forms. Can you move to the next slide? Yeah. So we evaluated various machine learning algorithms to obtain the one that performs best in our application. We did 10-fold cross validation for each algorithm, meaning each algorithm was iteratively trained and tested 10 times during the 10 times using random data sample each iteration. So during the process, we found that logistic regression performed the best interclass prediction. So we went with logistic regression. If you look towards the image in the right, it describes the performance of logistic regression. The rows are the actual classes of documents, and the columns are the predicted classes. The column in the right corner is the actual number of documents in each class. The diagonal represents the correct predictions for each class. Here, if you look at the first row and first column, there's 23 highlighted in a different color. So for 25 documents in class 1, logistic regression predicted 23 documents is class 1, and two remaining ones is class 2. That goes for all the classes. That goes similar for all the classes. And then the table in the left just summarizes the image. So we are more concerned about the recall of the model, so we do not produce any false positives. If you look at the end of the table in the left, you can see that the weighted average of logistic regression model precision was 97%. So that is why we used logistic regression as our model. And to predict the unknown document, can you move to the next slide? To predict, so this table describes all the algorithm we use to build the model and all the and the precision and recall for all the models. And you can see that logistic regression performed best on the recall among all the other models. That was 97%. And if you move to the next slide, to predict, this was the code for the logistic regression model we used and all the parameters that we set. And next slide, please. And to predict the unknown documents, we assessed a confidence level for each class. And if the confidence is not at least 80% for any one class, we flag the document as unclassified. As far as we have tested, the software performs pretty decent at 80%. However, this threshold can be adjusted if required. After the document is classified, it is passed to signature detection subsystem, which Pawan will explain next.
Thank you, Sandesh. Good morning, everyone. I'm Pawan, and I'll be talking about the signature detection system. So signature detection is an important feature of the identiDoc system that is able to identify signed and unsigned documents. So once a document is classified as a known document, it is passed to the signature detection unit, and this unit uses a trained model to predict whether or not a signature is present on the document. Next slide, please. So as per our requirement, our task for signature detection was straightforward. Given a known document, we had to identify if signature was present on certain section of a document. So for something like the picture on the left, the model was expected to predict signature present, and for something like the picture on the right, the system was expected to predict signature missing. Next slide, please. So talking about our approach for signature detection, the signature detection was approached as an object detection task. Object detection is a technique that is used to find, locate objects and images and videos. So given a document from a known class, what we wanted to do was first locate the signature on the document, and then localize the signature using a bounding box. So for this we created a custom object detector using YOLO v3. YOLO is a real-time object detection system, which takes an image and passes and outputs the class level and the prediction scores in just one run of the algorithm. And the reason for choosing YOLO was its speed, and also because a lot of open source implementation of the YOLO version was available online. Next slide, please. So the first step in creating our signature detector was creating a custom label dataset. For this, we collected about 1,000 signed known documents, and we labeled each document using label IMG. Next slide, please. So this slide shows how we labeled the data points using label IMG. So we're just drawing a bounding box around the signature, and this will produce a text file that was later fed to the model to help it identify the signature. Next slide, please. So following the last slide, on the right you can see the annotated text file. So the first entry is the class ID, which is 0, since we are training on only one class. The second and third entry are the center point of the bounding box, and the last two entries are the height and width of the bounding box. Next slide, please. So once we completed training our dataset, the second step was training the object detector. We used a train test split of 70-30 and created a custom CFG file with customized variables like height and width of the data being passed, maximum number of batches, steps, filters, etc. So for example, the recommended value for the number of max batches was 2,000 times the number of classes, which should have been 2,000 since we have only one class. But just to allow our model to have more learning iterations, we set that value to 6,000. Likewise, the other variables that affected the learning rate were set accordingly. And once that was done, we used DarkNet, which is an open source neural network framework. And with the motive to make our network learn faster and be more accurate, we also performed transfer learning from convolutional layers. Next slide, please. So doing this, we were able to achieve a mean average precision value of about 92.07%, which is pretty good. And also the system is pretty fast. So once the image is passed, it gives the output in less than a second. Next slide. Okay, yeah, that's all for our presentation today. Thank you all for your time and attention. And if you guys have any questions, we'd love to answer those. Thank you.